Welcome to a preview video of our concurrent session at the SNOMED Expo 2023 in Atlanta called Beyond the Browser Terminology as a Wiki. We've undertaken an effort to load the SNOMED IPS terminology into an Atlassian wiki and link it to related resources such as the ICD-10 and have catalog pages for map sets and ref set content. We're going to do a little demo as part of this tour that's built off of an Ultra Mini, but when we do this session for real, the full content will be available on the site. So what did we do here? Our goal as a company is democratizing access to healthcare terminology content. So we're interested in supporting a wider audience. All users of all different levels of sophistication and technical acumen should be able to interact with terminology content. SNOMED is at the forefront of standards revolution, and it's good for SNOMED and the other providers of such content to have as wide an audience as possible of users and stakeholders to contribute, to interact with, to understand, and to learn about how healthcare terminology works and how it can be used in real world scenarios. Normally, tooling for interacting with SNOMED CT requires some amount of technical understanding or expertise. Things are surfaced that are fairly complicated. In a wiki, we even have the opportunity to link to training resources and other sorts of things. And ultimately, we're looking to engage a larger community to collaboratively develop content and things like that. By using a wiki, we spend less time building software components because there's a lot of stuff already included, and it's a kind of natural way to display the information. So we can focus more attention on presenting the content and derivatives of that content. And we get things for free, like mobile browsing, user management, scaling to essentially any number of users, including the ability to have a public distribution of the content. So paid users don't have to be the only ones who can access it. Obviously, as a content management environment, wikis have search and retrieval mechanisms, user interfaces people are familiar with. They support multimedia, so things like images and videos and other rich content beyond text. And one of the things we've done here is to add a layer to demonstrate how we can do structured collaborative editing, sort of with a bit of a bridge outside the wiki itself. We've taken SNOMED CT RF2 files for this IPS, the International Patient Summary sub-ontology of SNOMED, which is licensed unrestricted, and some ICD-10 CM content from the UMLS in RF form. We loaded concept information such as codes, descriptions, text definitions, and properties. We could supply translated content for use cases that involve multilingual participants. Inline, we can have direct linking of parent and child concepts so you can walk the hierarchy. We can show the defining attributes of a concept, so the SNOMED concept definition sort of view into the relationships file with grouping and dereferencing of the IDs, navigation so you can crosswalk the defining relationships of a concept as well. We could show the OWL axioms themselves to layer in some technical information, ref set membership, participation in mappings, historical information, things like, what codes were mapped into one, or for an inactive code, what its replacements would be, things like that. And we could associate to other information. So in the context of a particular concept, do things like show the machine readable concept model rules for that thing. There's also an opportunity in this wiki to build enriched derivatives of the data. So we built an engine to generate concept diagram files at scale that we can use to load into the wiki. So all concepts of the IPS have a concept diagram now, computed from the actual data of that set, and it's just inlined into the pages. We did a project this summer to use GPT-4 to generate and review by humans text definitions. The idea that at some level of scale, we could actually have textual definitions for, let's say, all primitive concept in SNOMED, something like that. These are an extra data source that we've brought in to just show in the wiki. We're presenting how you could include technical data models, JSON representations of the data for technical users, and that could be integration points for actual tooling. We could show QA information inline in the pages. We can show Refset and Mapping membership, both inline in a concept and from the catalog direction of all of the entries of a Refset or all of the mappings of a mapping. And then we can have content management features. We've added suggest a synonym and suggest a child concept buttons. with the idea that these decorate the page with some technical payload that could be pulled out and put into an authoring environment, a content submission request environment, which then feeds an authoring environment. And of course, wikis have natural user engagement functions too, like comments and starring pages and other things related to that. We considered various options. There's a lot of choices out there for content publishing. Go, Hugo, Gitbook, GitHub has GitHub pages and there's wiki mechanisms. In the end, we settled on Atlassian, in part because of its adoption by the SNOMED community as a sort of tool of record, because it has an API, because it's sort of infinitely scalable and comes with a lot of extra features. You can see a couple of screenshots on the right here of the mobile view of the wiki. So we get a mobile view of terminology content essentially for free without having to do any extra work. There's a lot of advantages of a platform like Atlassian. It supports unlimited amounts of content and scaling for unlimited users. It handles user management if you want restricted access to editing and things like that. And it supports features like downloading the entire thing as a PDF if that's what you want to do. Architecture diagram shows kind of what we've done. We started with some data files. There's a few other data assets not shown. We have a builder application that generates concept diagrams from a service that we wrote based off of the SNOMED browser diagramming tool. This all gets fed through the Atlassian API into a Confluence instance that then presents pages to users in a web browser. The functional features are buttons on this page, which link to a backend service that presents a form to the user to fill out, which then redirects them back to the page after having decorated that page with a sort of content payload representing their request. The idea of all this is this environment could be picked up by a content request submission system and sent to an authoring tool. So this provides an opportunity for collaborative community maintenance out of the box, essentially, for the ability to have structured data entry. People can suggest all of the variety of things that the current content request submissions support, but in a way that doesn't actually do anything except populate the wiki with this suggestions. Those suggestions can, in an organized way, be fed into an environment for consideration for inclusion, or the community can continue working on them for a period of time. And then the whole thing can essentially be closed loop by republishing all of the content changes, highlighting the diffs, the whole thing. So it's sort of end-to-end content maintenance is the idea. Okay, now we'll take a look at a quick demo of the tool. So here's the wiki itself. We've got a top-level page showing what content we have. Like in ArcSNORM are really stub pages to show that we could have other stuff in here. If we go to SNOMED, there's a kind of top-level page that shows the upper level of the tree and then which ref sets and map sets are loaded. Again, this is a mini data set. The full data will be available at and after the conference. And here on the left, we can sort of navigate the tree of SNOMED and find our way to a concept. So here we go. This is an example of a concept page. Viscous structure finding. Code is up here. There's a summary. This is an active thing from this version of the data. It last changed July of 2022. It's defined and part of the IPS module. No text definitions. Here you can see our suggest a synonym button. If we do this, we can come and suggest a synonym. And if we fill this form out and do that, it essentially adds a payload to the end of this file that represents that request. So here you can see I did this earlier. For this concept, we want to add this description. Here's the notes. This is some information about what page it's on. The form filled out essentially. This payload could be extracted via the API and fed directly into a content request system. Now you might be thinking, well, this is only one synonym request. This whole wiki could also have a structured form to accept batch requests, in which it could create new pages representing provisional content from the requests. We took this only so far to demonstrate what we were trying to do with it, but there's many more directions that we could go. We're showing the descriptions here. So the terms, the term types, fully specified name, and then language preferences. So this is the preferred British English and the preferred English description of fully specified name description. Here you can see parent and child concepts, and we've got another button for suggesting a child, which means people can suggest new concepts, but need to sort of think about where in the tree they would want to put it. And that can come with a form with as much richness as you want to require in terms of pre-modeling of new content. The defining attributes, we can show sort of what the concept definition of this is, whether it participates in refsets or mappings. And then the concept diagram here is inlined. We've got a few links to a couple of browsers, the West Coast Informatics IPS browser and the SNOMED browser. And then here's a bit of a thing for technical users just to show this is the JSON payload or a version of it that comes out of, that's used by the browser, the SNOMED browser, to actually show the content. So that's SNOMED. We also have ICD-10-CM in here because we've mapped. So if you kind of look at the mappings, we do have a map to an ICD-10 code here. And so we have ICD-10 pages as well. Similar summary information. Here we've got the descriptions for ICD-10, parent concepts. We include a little diagram. It's sort of silly. This is not an ontology, but this kind of shows that heart disease is a child of I-51 complications and ill-defined descriptions. These pages are a little shorter because there's less information to provide, but you get the idea that we can sort of show the variety of content here. We've also encapsulated the catalog of refsets that are available. These are not all included in the IPS or in our mini subset, but we've layered them in from various other sources published by NLM to show that we can incorporate this other content. Something like the global patient set, we can essentially list all of the members with their names. And then mappings are similar. Right now, we just load the SNOMED to ICD-10-CM mapping, trying to keep this all to content license unrestricted content. So this is the SNOMED IPS map. Essentially, what we'll show is concepts from the IPS map to ICD-10-CM. In this case, again, it's just the mini, so there's only a few entries. And then this table can be searched in a variety of ways and so on. So that's just a quick presentation of what's possible. There are so many directions that this could be taken, and we hope to see groups adopt this approach to publishing content for non-technical users to let them interact in a more meaningful way, and eventually build up the presentation of derivative aspects of the content and really show a full-featured interactive environment of what terminology content is about. Thank you very much. We'll stop there.